Greetings everyone. Today we are going to derive a derivation from our 5 marker series. Okay, for our 5 marker series, electric charges and from the chapter electric charges and fields. The derivation of expression for electric field on an axial line of an electric dipole. So before starting this, we'll just discuss some amount of uh, basic concepts here. So the first concept is an electric dipole is made up of two charges. It is dipole plus minus q and plus q. Always they are separated by a certain distance. We'll represent it with 2a. And always the direction of the dipole moment is vector p is from minus q to plus q. Okay, so dipole moment is a vector quantity, and the formula for dipole moment is given by q into 2a. q into 2a. And other basic that what we should know is electric field is equal to 1 by 4 pi epsilon naught q by r square, where r is the distance from the point where we are supposed to calculate the electric field to the point where the charge is located. So these are the two basic things which we should know to do this derivation. Okay, so now let us start with the derivation. So he is asking an expression for an electric field due to a dipole along an axial line. So for that, let us assume or consider two charges plus q, which is separated to a distance by minus q. These two, let us assume that these two are separated by a distance of 2a. The direction of the dipole moment is from minus q to plus q. This is always there. And let us assume a center point O, mark a center point O, which is at a distance a from plus q, and similarly at a distance a from minus q. Now let me assume a point P, which is actually at a distance r from the center of the dipole. Now, since the point P is at a distance r from the center of the dipole, the point P, okay, it is from a distance of r minus a from a charge plus q. Sir, why it is so? When you ask me why it is so, see here, from P to center, it is r, and from center to this one it is a, from center to plus q it is a. I want only distance from P to plus q, therefore it is r minus a. Similarly, if you ask me what is the distance from P to minus q, then it is at a distance of r plus a. Okay, don't confuse with this P and this P. This is the P where we are actually calculating the field due to the dipole, and this is a P. This is a small caps P. Okay, small case letter P, which actually representing the dipole moment. Okay, so now it's the time to calculate the electric fields. Generally, we know that like charges attract each other and unlike charges repel each other. Whenever we are finding a electric field at any point, we'll place a test charge which is plus 1 coulomb. And when I place a test charge plus 1 coulomb, plus 1 and plus 1, they will repel with each other. Therefore, the electric field due to a plus q of a dipole is away from the dipole. Therefore, it is given by E plus. And similarly, when we consider the minus q here, since it is plus 1 coulomb, the minus q, it is attractive in nature. Therefore, it is attractive towards E minus. Therefore, when I assume the net electric field, when we want to check with the net electric field, what is the thing we have? The net electric field is the total electric field. So total electric field means one electric field is going towards the left and other electric field is going towards the right. Therefore, total electric field E net is equal to E plus minus of E minus. Am I right? Therefore, E plus is equal to 1 by 4 pi epsilon naught. What is the charge? Q divided by what is the distance? R minus A whole square. And similarly, I have E minus is equal to 1 by 4 pi epsilon naught Q divided by what is the distance? R plus A. Am I right? From P to minus Q, the distance is R plus A whole square. Therefore, substituting this, let me call this as equation number 1, and let me call this as equation number 2, and let me call this as equation number 3. Let us substitute equation 1, 2, and 3 into 1. Okay, let us substitute them. Then what I will get, E net is equal to, since Q by 4 pi epsilon naught is common, I am taking them out, Q by 4 pi epsilon naught and 1 divided by R minus A whole square minus 1 divided by R plus A whole square. That is equal to Q by 4 pi epsilon naught into R plus A whole square minus of R minus A whole square divided by R minus A whole square into R plus A whole square. We know that R plus A is nothing but A plus B whole square. Therefore, I'm using that formula also here. A plus B whole square is equal to A square plus B square plus 2AB. And similarly, A minus B whole square is equal to A square plus B square minus 2AB. Okay, we know these things. And we also know that A square minus B square is equal to A plus minus B and A plus B. So on squaring both sides, we'll get A square minus B square whole square is equal to A minus B whole square and A plus B whole square. So ಇದನ್ನು ನಾವು ಮಾಡಬಹುದು a square a minus b whole square plus a plus b whole square. Just see ಇಲ್ಲಿ denominator ನೋಡಿ r minus a whole square into r plus a whole square can be written as a minus b a whole square plus a plus b whole square can be written as a square plus b square whole square. So in the next slide we'll just do the things. Therefore, finally we have E net is equal to Q by 4 pi epsilon naught into ಏನೇನಿತ್ತು ನಮಗೆ R plus A whole square minus of R minus A whole square divided by R minus A whole square into R plus A whole square. So this can be written as Q by 4 pi epsilon naught into R square plus A square plus 2AR minus of R square plus A square minus 2AR divided by R square minus A square whole square. This is what I have already discussed. ನಾನು ಆಲ್ರೆಡಿ ಹೇಳಿದ್ದೆ ಈ ಫಾರ್ಮುಲಾ ಯಾಕೆ ಬರೀತಿದ್ದೀನಿ ಅಂತ, ಹಾಗೆ ಇವನ್ ಐಡೆಂಟಿಟಿ ಇನ್ ದ ಬೇಸಿಕ್ಸ್. Therefore, E net is equal to Q by 4 pi epsilon naught into R square plus A square plus 2AR minus of R square minus, sorry, R square minus A square minus into minus plus 2AR divided by R square minus A square whole square. R square cancel aitu, A square also gets cancels. Minus into plus, my plus. Therefore, Q by 4 pi epsilon naught times 4 times AR. 4 ಇದೆಯಂತ ಹೊಡೆದಾಕ್ಬಿಟ್ರಪ್ಪ ದಯವಿಟ್ಟು. Okay. Sorry, R square minus A square whole square. This can also be written as 1 by 4 pi epsilon naught. Okay. So ದಯವಿಟ್ಟು 4 ಕಾಮನ್ ಕಾಣಿಸಿದೆ ಅಂತ ಹೊಡೆದಾಕ್ಬೇಡಿ. Q into 2AR into 2 ಅಂತ ಬರೆಯೋಣ. Divided by R square minus A square whole square. That is equal to 1 by 4 pi epsilon naught. Already ನಾವು ಬೇಸಿಕ್ಸ್ ಅಲ್ಲಿ ಮಾತಾಡಿದ್ವಿ. ಓಕೆ, Q into 2A ಅಂದ್ರೆ ಚಾರ್ಜ್ ಇಂಟು ಡಿಸ್ಟೆನ್ಸ್ ಈಸ್ ನಥಿಂಗ್ ಬಟ್ ಡೈಪೋಲ್ ಮೊಮೆಂಟ್, ವೆಕ್ಟರ್ ಸಮ್ ಆಫ್ ಅ ಡೈಪೋಲ್ ಮೊಮೆಂಟ್. ದೇರ್ ಫೋರ್ ಇಲ್ಲಿ ಕೂಡ ಅಷ್ಟೇ, ಇಫ್ ಯು ಅಬ್ಸರ್ವ್ ದಿಸ್ ಒನ್, ನನ್ನ ಹತ್ರ ಏನೇನಿದೆ, ಒಂದು ಕ್ಯೂ ಇದೆ, ಆಮೇಲೆ ಇನ್ನೊಂದು ಕ್ಯೂ ಅಂಡ್ ಅನದರ್ ಈಸ್ 2A. ಇವೆರಡೂ ಸೇರಿಸಿದ್ರೆ ವಾಟ್ ಐ ವಿಲ್ ಗೆಟ್ ಪಿ. ಏನ್ ಸಿಗುತ್ತೆ ನನಗೆ? ಪಿ. ಪಿ ಮೀನ್ಸ್ ಡೈಪೋಲ್ ಮೊಮೆಂಟ್. ದೇರ್ ಫೋರ್ ಐ ವಿಲ್ ರೈಟ್ ಇಟ್ ಆಸ್ ಪಿ ಇಂಟು 2R divided by R square minus A square whole square. Therefore, E net is equal to 1 by 4 pi epsilon naught 2 times PR divided by R square minus A square whole square. Okay. So now this is our final output. ಈಗ ಇದನ್ನು ನಾವು ವೆಕ್ಟಾರ್ ಫಾರ್ಮ್ ಅಲ್ಲಿ ಬರೆದ್ರೆ ಈ ವೆಕ್ಟಾರ್ is equal to 1 by 4 pi epsilon naught 2 times vector P into R divided by R square minus A square R cap, P cap, sorry, P cap. So for a short dipole ಅಂದ್ರೆ ಏನು? For a short dipole, okay, R is very much greater than A, means the separation between the two dipoles is 2A and two poles is 2A. If I am taking very large distance from it, okay, when compared to 2A, R is very much greater, then we call it as a short dipole. In such situations, we neglect A, then my electric field E is equal to 1 by, 1 second, sorry, some technical aspect. Can be written as 1 by 4 pi epsilon naught 2 times PR divided by, since A itself is smaller than R, A ನೇ ಸ್ಮಾಲ್, R ಗಿಂತಲೂ ಬಹಳ ಚಿಕ್ಕದು, ಸ್ಕ್ವೇರ್ ಮಾಡಿದ್ರೆ ಅದಕ್ಕಿಂತ ಚಿಕ್ಕದು, ಹೌದಾ? ಯಾಕಂದ್ರೆ 0.1 ಸ್ಕ್ವೇರ್ ವಿಲ್ ಬಿ 0.001, ಸೊ ಅದಕ್ಕಿಂತ ಚಿಕ್ಕದಾಗತ್ತೆ. ಸೊ ವಿ ನೆಗ್ಲೆಕ್ಟೆಡ್ ಅಂಡ್ ವಿ ಹ್ಯಾವ್ ಅ ಸ್ಕ್ವೇರ್ ಹಿಯರ್, R into R square to the power of square, or R square to the power of 2 can be written as R to the power of 4. So ondaru gets cancelled. Therefore, finally, I will have an answer. Dipole moment, electric field. Sorry, for along an axial line for a dipole, the electric field is given by 1 by 4 pi epsilon naught into 2 times vector p divided by r cube. So this is our final expression where we are supposed to stop this thing. Okay. So if want a notes for this, you can check into the Telegram channel link ಕೂಡ ಕೆಳಗಡೆ ಕೊಟ್ಟಿರ್ತೀನಿ. Okay. Notes ಬೇಕಾದರೂ Telegram channel login ಆದರೆ if you can subscribe and you can download the notes for this derivation. Thank you.